Hello, this is Dr. Brown. In this video, we're going to do the third installment on our probability series. And we're going to be talking about counting and probability. This is on page 297 to 309 in the textbook. We're going to now talk about some fundamental counting principles. If you have m items in one category and n items in another category, then the total number of available choices is just m times n. And the principle can be extended to more than two categories as well. Example, suppose at a restaurant you have 8 choices for an appetizer, 11 choices for a main course, and 5 choices for dessert. The total number of choices is just the product of all 3 choices. So you have 8 times 11 times 5 is 440 choices for the different meal combinations. Now we have a definition called factorial. It's a non-negative integer n is the product of all positive integers less than or equal to n. So n factorial is n times n minus 1 times n minus 2 all the way down to 1. Example, 5 factorial is 5 times 4 times 3 times 2 times 1 equal 120. Now, if you use the calculator we've been using lately, you won't even have to use the factorial. You'll just be able to do these combinations without it. But that's what n factorial is. Now, here's an example here. You got a charity event attended by 25 people, and you have 3 gift certificates given away as door prizes in the amount of $100, $25, and $10. Assuming that no person receives more than 1 prize, how many different ways can the 3 gift certificates be awarded? Okay, well, to start off with, there are 25 people attending, so there are 25 people that could get first prize. After that is given away, there are 24 people left, and so there are 24 that could get the second prize. And then after that prize is given, there are 23 people left. So the total number of combinations, number of ways that these awards can be given or prizes can be given is 25 times 24 times 23, which is 13,800. Now, the definition here is permutations. We say that there are P sub n sub r permutations of size r that may be selected from among n choices without replacement when order matters. So we're going to use this to find the number of combinations, or really permutations, when the order that you pick them in matters. And it's n p sub r is equal to n factorial over n minus r factorial. And it turns out that you can calculate this on your calculator. Suppose you wanted to calculate, in fact, permutations taking 5 at the time. We're going to be able to calculate this by putting the 10 in and hitting probability And we're going to be doing permutations here. So we're going to pick number 1, and we're going to do it 5 at the time. And we get 30,240. The next definition is combination. And we say there are a combination of n things taken r at the time without replacement when order really doesn't matter. And that's calculated by this formula. And here again, you're not going to have to actually use this formula because you can do combinations of n things taken r at the time using the calculator. And I'm going to show you an example here. The United States Senate Appropriations Committee consists of 29 members. And the Defense Subcommittee of the Appropriations Committee consists of 19 members. Disregarding party affiliation or any special seats on the subcommittee, how many different 19-member subcommittees may be chosen from among the 29 senators on the Appropriations Committee? Since the order does not matter here, we're going to use combinations of these 29 members on the Appropriations Committee, taking 19 at the time. So how many 19-member committees can we choose from the 29? It's going to turn out to be quite a lot. I'm going to bring up the calculator here. And clear it out. We want to do combinations, so we want to do 29, hit probability, and here we want to pick the combinations choice, number 2. So hit enter, and now we're going to put 19 in, and then we're going to hit enter, and notice we get 20,030,010 possible combinations. Now let's go to the state lottery. We're going to use probability using permutations and combination. In a certain state lottery, 48 balls are numbered 1 through 48 are placed in a machine, and 6 of them are drawn at random. If the 6 numbers drawn match the numbers that the player has chosen, the player wins $1 million. In a lottery, the order the numbers are drawn in doesn't matter. So we want to compute the probability that you win the $1 million prize if you purchase a single ticket. What you need to do is calculate the number of ways to pick 6 balls out of 48. That would be a combination of 48 things taken 6 at the time. And there's the answer, and I'm going to show you how to get possible combinations. I'm going to clear it. We want to do 48 probability. Here again, we want to do combinations, and we want to do it 6 at the time. Hit enter, and we get 12,271,512 are the number of possibilities. And you have one chance out of that 12 million or so of being a winner. So if you take 1 and divide by 12,271,512, you get this probability, 0.000000815, which can be written as 8.15 times 10 to the minus 1, 2, 3, 4, 5, 6, 7, 10 to the minus 8. So you have very little chance of winning the lottery. let's look at another example of using permutations and combination. Most of this is going to be combination if order doesn't matter. We want to compute the probability of randomly drawing 5 cards from a standard deck of cards and getting 3 aces and 2 kings. So you got to get 3 aces and 2 kings in order to be a winner. First of all, you need to break this up into separate events. One is to find the number of ways you can get 3 aces out of the 4 aces that are in the deck. Because obviously there are 4 aces in a deck and you want to get 3 of those. That would be a combination of 4 things taken 3 at the time. And I'm going to stop and do this. The answer is 4. Put in 4 probability. We're going to do combinations, taking 3 at the time. And something did not go right. I think I hit the wrong one. We're going to put 4 probability. And we're going to do the combination. Okay, that looks better. Be careful and check your work. Doing 3 at a time, and we get 4. So the ways to get 3 aces out of 4 aces is there are 4 possibilities. Now we want to look at the number of ways you can get 2 kings out of 4 kings. Notice there are 4 kings in the deck. Getting 2 of those is going to be a combination of 4 things taken 2 at the time. And let's do that one. It's 4 things. Here again, make sure you pick the combination. And you want 2 at the time. And you get 6. Now, the number of ways you can get 2 kings and 3 aces, that's two of these events in a row, is going to be 4 times 6. The product of 4 and 6. There's 24 possible ways to win. Now let's look at the total number of ways you can get 5 cards out of a deck of 52. That would be a combination of 52 things taken 5 at a time. And we will do that one. Let me get this up here. When it clear, we want a combination of 52 things. Probability. Be sure you get the combination. Taken 5 at the time. This is the total number of ways you can draw 5 cards from a deck. And that number is 2,598,960. So the probability is going to be 24 out of 2,598,960, which is this decimal, which is the same as 9.234 times 10 to the minus 6. So you have a very small chance of randomly drawing 5 cards from a standard deck of cards and getting 3 aces and 2 kings. Now the last example, we have a jury pool consisting of 27 people, 14 men and 13 women. Compute the probabilities that you could select a jury of 12 people that's all male. So let's look at the total number of ways from the 14 men. You could pick 12 to be on the all-male jury. Well, that will be a combination of 14, taking 12 at the time. If you'll do that in your calculator, you'll see that it's 91. And the total ways that 27 people, from the 27 people of picking any 12 people, whether male or female, is a combination of 27 taking 12 at the time, which you can see is 17,383,860. So the probability of getting an all-male jury is still going to be very slim, which would be 91 over this 17 million number, which is this decimal, and it's 5.235 times 10 to the minus 6. And that is the video.